Hello, this is Farhan Kalim and my topic is prevention of SQL injection attack using encryption and hashing. I'll be going through introduction, goals, related work, proposed model and algorithm, evaluation and conclusion. Here, I would like to explain that what is SQL injection attack. We can consider an example of a web application that is having a login page on the front end and on the back end there is an SQL database. On the login page, the user can enter the user credentials which will be going on the back end. On the back end, using this credentials, the SQL query will be formed and it will be fired on the database. That will return either true or false. If it is true, you get access. If false, you do not get access. Now, the attacker can on from the front end can enter the malicious code which always return into the true. So it easily gets access into the system. This is known as SQL injection attack, and according to OWASP top 10, SQL injection ranks number 1. That is, most of the websites are vulnerable to this attack. The goals of the paper is like how can we prevent this SQL injection attack, which algorithms we'll be using and why. The research question is, can SQL injection be prevented using a script hashing algorithm and AES encryption algorithm? During the time I went through various papers. First paper was a classification of SQL injection attacks and countermeasures. Here, the system was designed which was classified into two parts, front end and back end. In front end, the user credentials were hashed and concatenated together. In back end, the SQL query was tokenized and put into the dynamic table and was sent into the server side. Along with the dynamic table, the SQL query was encrypted and was also sent onto the server side. On the server side, this encrypted SQL query is decrypted and is tokenized and again stored into the dynamic table. Then these dynamic tables are compared, and if they match, then it means that there is no SQL injection attack. The drawback for this technique is that the dynamic table used is not encrypted and it is in plain text, and there is more burden on the server. The next approach was in the paper a survey on web application vulnerabilities. They were designing a system that was SQL injection in SQL injection protector for authentication, that is SQL IPA, that stores the hashed credentials for the users, and it was less complex as compared to the previous paper. The drawback here is that is implemented only on the login page and not on the other pages. The next paper I went through was a study on SQL injection attacks, mode detection and prevention. The approach that was used here is that the database stores the username and password in the plain text along with the user secret key as they use the AES algorithm. This user secret key is unique for different users. When during login time, the user credentials are encrypted and using the secret key, it goes to the server side. On the server side, this credentials are decrypted and they are compared with the database. The drawback here is that the user credentials stored are in the plain text is stored into the plain text, and there is no proper mechanism for key distribution. The next paper I went through was a novel method for preventing SQL injection using SHA-1 algorithm and syntax awareness. Now here, the SQL query was hashed using the SHA-1 algorithm. The drawback here is the SHA-1 algorithm is prone to rainbow table attack and brute force attack as it is very fast algorithm. The next paper was using the similar approach, that was forming the query using the user credentials and was hashing the entire query using SHA-1 algorithm. And as it is using SHA-1 algorithm, it is having the same drawbacks as of the previous paper. So we proposed a model that was classified into two parts: the SQL injection prevention technique for embedded SQL queries and the prevention technique for stored procedures. In the first part, during registration, the user enters the username and password that are hashed using the script algorithm. Then they are encrypted using the AES algorithm, so we get the two level of protection, and then they are stored into the database. During login, the username and password, when they are entered, the SQL query is formed using them, and this SQL query is hashed using the script algorithm. Then from the database we fetch the stored SQL query that is decrypted using AES algorithm, and both the hashes are now compared. If the hashes match, then the user is authenticated and the access is allowed, else there is SQL injection attack and the access is denied. The next technique is SQL injection attack prevention technique for stored procedures. Here we use a simple blacklisting technique, that is we compare the input by the user, if it is the malicious code or not. If it is, then we ignore the input, and it is the SQL injection attack, else the access is allowed. Next is like how will we be evaluating this system? The evaluation will be done on two bases, based on reliability and the response time. The reliability will be tested by using the self-generated data, like how the system will handle the various SQL injection attacks, and the response time using the Apache JMeter tool. The response time should not be too fast, because if it is too fast, then the brute force attack will become very easy, and if it is too slow, no one will be interested in using the application. So overall, I would like to summarize now. I had a talk upon like what is SQL injection attack and why it is important, the existing approaches and the drawbacks in them, the proposed algorithm, the evaluation that will be done based on the inputs, and the response time. And we will begin this setup infrastructure of the proposed model and implement the algorithm in the next semester. Thank you.